we are going to see queue using linked list. Okay, the implementation of queue using linked list. Okay, right? So we have seen a queue can be implemented in array, but what's the drawback of it? Okay, the size of the array is fixed. If you allocate a space for 50 elements in a queue, it is hardly uses 20 to 25 locations. It will not use the entire 50. Okay, so the remaining spaces will be wasted. And in case if you allocate a less memory location for queue, then it might end up in growing a large and large. Then a lot of reallocation we have to do. So it's always time consuming, and it is not appropriate method. Choosing an array is not appropriate method for implementing a queue. So in the case the queue is very small, okay, or the maximum size is known in advance, then the array implementation of the queue gives you an efficient implementation. But if the array size cannot be determined in advance, right, then the alternative is you have to go for the linked list representation. Okay, the storage in the linked list representation of a queue with n elements takes the order of n. Okay, for one it is order of 1. So in the linked queue, right, every element has two parts. Okay, we have seen a linked list implementation. Linked list means it will have only two parts. One is data part, other one is address of the next node. Okay, so here the start point of the linked list is used as the friend. The start point is used as the friend. Okay, and another pointer here. Okay, which will store the address of the last element. Okay, last element. Okay, so all the insertion will be done at the rear end as we seen in the array. Okay, suppose if the rear and the front is null, it's a queue is empty. If rear and front is null, then the queue is empty. Okay, now we'll see the linked list representation of queue. So let me just insert a shape. First create one's normal shape, and then let's go for formatting. Okay, and then take this and make it straight. It's not straight. Okay, okay, so we need to group it. So let me have 4 elements. Okay, next create an arrow. It should be black. Yeah. This is not required. So as I told you, always um, always the last element is the next node of the last element is null. Now if we just keep this closer, keep this closer, keep this closer, that's all. Right, yeah, and I need to push this as well. Yeah, so as I told you, this is the setup that we're gonna have, and let me have a text box without any border. Let it be the value like 3, and I'm not gonna have any border for this. uh, I only need border for this, for my shape, line, no, that's it. Okay, let me shrink it. Yeah, right, this is 31. Now let me make it as 8, 7, then again paste it. Let it be 9, paste it. Let it be 4. Okay, that's it. Thanks for your patience. Fine, right? So this will be the front, and which will be the rear. This will be the rear. Okay, this is what is linked queue, right? So whenever I want to delete, I want to delete at the first. Whenever I want to insert, I want to insert at the last. We already seen, right, the algorithm, how to insert in a queue at the last, at the first. Okay, in the linked list we have seen how to insert at the last, how to insert at the first, right? Now we'll see the algorithm. Okay, so what is the algorithm? First we need to allocate a memory using malloc. Allocate a memory for the new node. Okay, right? Next is what? Next we have to set pointer. Okay, and name this as a pointer, and name it as pointer. Okay, set pointer of data is equal to value. Okay, so as I told you, if front is equal to null, okay, if front is equal to null, okay, set front and rear equal to pointer. Front is equal to rear is equal to pointer. Okay, and what is the front of next? Front of next would be the front of next, and rear of next would be null. So the front of next equal to rear of next equal to null. Okay, otherwise, I mean else, in the else part, set rear of next equal to pointer, and set rear is equal to pointer. So what is this set? Why I'm setting rear of next, okay, as a PTR? So first I'm checking front is null. Okay, right? So in the first step, what I checked, I just allocated memory. In the second step, I added the data part. Okay, because in the node I have data part and the next node. Right. So if we check the new node is a first node. Okay. Then okay. How do I check the new node is the first node? If the front is equal to null. Okay, which means that is the first node. That new node is the first node. If this is the case, then the new node is tagged as the front as well as the rear. Okay, right? Both because we have only one node, that is the new node. That new node is the front and also the rear. Okay, so the null is stored in the next part of the node because that is the only first node. Suppose in this case, if I have only three, so three will be the front, three will be the rear, and three will be the last node. So I have to put the next as null. However, if new node is not a first node, then it has to be added at the rear, which means add at the last. How do you add the last? We just create, right? So what do? We just make the rear of next as the pointer. That's why making set rear is equal to pointer. Rear of next is the pointer. Next I am making the rear as the pointer ptr. Next the rear of next is the rear, yeah, the rear of next is null. Okay, suppose say for example assume that this is the 9 is the last value that you have. Okay. Mm, let me just do something here. Assume that 9 is the last node. Let's remove the line. Hmm. So now you see the 9 is the last node. Assume 9 is the last node. I want to insert. So first I have to check, right? So in the insertion, I have to check whether the front is null or not. No, front is not null because the front we have value 3. Got it. Okay, clear. Now come to the else part. In the else part, what I have done, rear of next is equal to the pointer. What is a pointer? The pointer is always a new node because what I'm doing it here, create a new node and make it as a pointer. So when I create a pointer, that's a new node. Okay, that is where this one comes. Okay, now the new node comes 4. Okay, right? So at first, now I can delete this one. At first, what was there? 9 was there. Now this is the actually PTR. Okay, right? This is the front and this was the rear. Okay, what is the rear of next? The rear of next is the PTR. So I just made the link. Rear of next is the PTR. Is it done? Okay, so rear of next is the PTR. Next, rear is equal to PTR. So what I'm making next, rear is equal to PTR means what? PTR is the rear. Now this is what the rear and this is what the PTR. Both are in the same place. Next I'm making rear of next as null. So this is what making the rear of next as null. Okay, so this is what insertion, right? So how do we do a delete operation here? Okay, so let me just take the same algorithm for, this is the algorithm for insertion, right? Let me just take this one. Algorithm for deletion. Now I have to delete the 3, right? So what is the algorithm for deletion? The first one is just first I have to check if front equal to null or not. Okay, if it is null, print underflow. Okay, next otherwise, right? we have to go to set ptr is equal to, if front is not null means we have some data. So ptr is equal to front. I'm making the front as ptr, so which means the front and ptr is same. Okay, right? And the front is equal to front of next. So how do I move this front pointer to here 7? I have to make set this is actually pointer now, that's what I represented here in the short form. Next, how do I move this front? As front, okay, set front equal to front of next. Okay, next is what? Free ptr, that's all. So if I free the ptr means what happened, the 3 will be gone, this will be deleted. Okay, I freed the ptr. Now this is the front and this is the rear. Okay, so this is what the linked list representation of for deletion. Okay, so what are we followed for the stack, we have to follow it for the queue. Now we'll see how to implement this using linked list. Okay, let's create an empty file. So hash include stdio.h. Okay, right, and then hash include, I have to use malloc.h, right? And then you have to create a node, right? So how do you create a node? Struct node. One is data part, so int data. Other one is struct node star of next, which is self-referential pointer that we need to create. Okay, and then semicolon here, and then we have to create a queue. Okay, which can hold the front and rear. Okay, which is of the type the same node. Struct node star front, struct node star rear. Okay, just keep semicolon here. It's done. Next I have to create one structure variable, struct queue star queue QE. Okay, right? So next we need to have a main function which is going to be a int main so I have to give int value, right? And how do we insert it? Okay, so let's have a function called void insertion. Let me have an insertion, so I have to pass a queue. Okay, in which queue I want to insert. Okay, queue space star queue comma int value. Okay, so I'm going to insert the value in the queue, that's why I given it passing it 2 parameters. So okay, so next we have to do what? Struct node, we need to create a pointer, right? So star pointer. Okay, and then I have to allocate a, this is the new node, right? So as per our insertion, we do allocate a memory and name it as the pointer, so that's what we are doing. Okay, so it is a not a ptr, it's a pointer. Okay, pointer is equal to, how do we allocate? We will allocate as a node size, node star, then malloc, and then the size of structure space node. Okay, and then I have to give the pointer of the data. So the pointer of data is equal to value. What I have to check? I have to check the q, to check the front, right? Front is null or not. So what of front? So the q of front equal to null. I have to print. I have to make what? I have to make the q of front as pointer. If that is the null means what? That is the first node I'm having in my queue, right? So q of front equal to pointer, and q of rear, that is also equal to pointer, because at the first node, okay, the first node, if I, that is the first node, then that will be the pointer, that will be the front, and that will be the rear. Okay, next what I have to make? I have to make the node next as null. If the first node, if there is only one node, then that node is the rear node, that node is the front node, that node is the pointer node, and the next of the pointer to the next node will be null, because it's only one data we have. So q of front equal to q of front of next the same way, q of rear of next equal to what? Null. Okay, right? If that is not the first, we already have the data. Okay, right? So I have to make the q of rear of next. Okay, next is equal to ptr. Okay, so rear of next is equal to I am creating the node after that, right? Next, q of rear is the pointer. It's not a ptr, it's a pointer. Okay, and q of rear of next is equal to null. Q of rear of next is equal to null. So we just created. Next, what we have to return? We have to return the q, so that we can print it. Okay, so we just created and save it as using linked list. Okay, fine. So because we have created a queue, the queue insertion, so the insertion must be a pointer. I cannot give void insertion because it has to return the pointer, no? Okay, so it should be the form of, because returning a struct, so this also should be a struct. Okay, so I can insert the data. So how do I display it? So I need to write one more function for it. So just keep this before the main, before the insertion. Okay, the same way, struct deletion, struct of node, sorry, struct of q of star. So here I'm not going to insert any value, so I can just put pass only the q. Okay, just pass the q and display the element. So because we have given a struct, right, so it is taken as this one. So struct q. So what we have created a queue. So queue u p u p. Okay, and this also should be the relation should also be a star. Okay, right? So we have delete. So how do we start deleting it? How do we start deleting it? So we have to check first in this. As usual, we have to mm, do whatever we have done for this one, right? Struct node pointer, right? So struct node star pointer. So once it is done, I have to make the pointer is equal to q of front. Next, I have to check if the front is null or not. So if q of front is equal to null, which means underflow, right? So printf underflow. Is it done? Next is what else part. So in the else part, you have to write a q of front is equal to. I have to move the front, right? Q of front is equal to q of front of next. So q of front of next. Okay. Next printf slash n the value deleted is colon personal d comma ptr of the pointer of data. Okay. So we just assign the front as pointer, and then we move the pointer, and then we deleting it. Okay. So we just printed now. Now we have to delete it. So free then bracket pointer. That's all. This will delete the q. Next, we have to give return q. Okay. So how do we display it? How do we display it? Struct q star display struct q star q as usual. Okay. So struct node star pointer as usual pointer, and then ptr is equal to q of, because I have to start from the beginning, right? If pointer equal to null, I have to say printf the q is empty, right? And then else part. So while pointer is not equal to q of rear. So why I'm checking this? I have to move until the pointer is not equal to rear. Okay. So next printf first ld slash d comma pointer of data. Next I have to move the pointer right, so pointer equal to pointer of next. Okay, at last need to open, I closed, then I have to print that data right after it reaches the last node, that also I have to print. So I am taking this as well, then return q. For if part it is there, files part it is there, and for while it is there, then after the while I have printf pointer. Okay, and then I closed it, return q. This one is closing. What is while else part? Okay, now it's fine. Now we need to call the main. Okay, so how do we do it in the main? So let's first insert the data. Okay, so printf, let me just copy, I'll take from here, control V, and so okay, let me keep it as a number, no problem, number. Okay, it is done. Next I have to give q equal to insert of, I have to pass q comma number. Okay, right, so this will insert the data. Next what happen to delete? Okay, q equal to delete or deletion. Is I given insert or insertion? I have to check whether I given insert or insertion. It's insertion, right? Insertion. Okay, insertion of q comma the value as, okay, let me just insert directly instead of asking 10. Okay, again if I want to insert, just q is equal to, first we'll do only one time and then we'll keep doing it later. Insert deletion, I have to pass struct. Okay, pass the q. Okay, so before insertion I have to display, right? So q is equal to display of q. This is q. So here we have given an insertion. It will insert the 10 and then display the 10 and then it will delete. Okay, so if you add q is equal to display again with q, this will give you the output. Okay,